Everyone, this is my video for ratios and enlargements in GeoGebra. I'm sorry if I have to rush this video, maybe my kettle will boil. What's a ratio? Well, if there are 3 oranges for every person, we'd write the oranges first, which is 3, and then the people second, which is 1. So a ratio could be 3 oranges for each person, or it could be 3 bicycles in every town. It could be written like that. So the first number might be bicycles, and the second number may be cars. They don't have to be the same thing. Whereas in a fraction, the top number and the bottom number are the same thing. So it's 6 meters over 11 meters. Whatever unit the top has, the bottom number has the same unit usually. Right. I'll do some questions now. If there are 2 carrots in every meal, we just have to write 2 to 1. So the carrots is first, and the meal is second. This question was a bit sneaky. For language reasons, I want the students to not worry about words that they don't understand and just pick out the key things. Well, there's 5 something in half a dozen something else. Some of them might not know half a dozen is 6, but they do now. That's it. Every time there's a yellow box, put an answer. We could also use ratios to describe enlargements or reductions. So 1 to 3 means getting 3 times bigger. So if the original object is size 1, after you enlarge it, it will be 3 times bigger, like that. So the way to work it out is it's always the second number divided by the first number. So it was 3 divided by 1 will give you a scale factor of 3. 1 divided by 3 gives you a scale factor of 1 over 3. Same in this one, it's 6 over 7, because the second number divided by the first number always. So that's how to change between scale factor and ratio, and that's the main thing that we have to do on the exam. But I added some more questions here. If the scale factor is 7, let's say it starts off at size 1, and it's going to get 7 times bigger. That will be an enlargement. But how about this one? Well, if it starts off at size 1 and it gets half as big, it's going to go down to 0.5. Well, we don't like it like that. We like it to have nice numbers. So it starts off, say, size 2, and then it gets half as big, and it's going to go down to size 1. So that's the same ratio as, that's the same ratio as this. 4 to 2, the first number is twice as big as the second. 2 to 1, the first number is twice as big as the second. But we say that's simplified because we can't make it any more beautiful and simple than that. Is it an enlargement or a reduction? It's a reduction because it's smaller afterwards. So it's a reduction. In these questions here where we have pictures and we have to say what's the scale factor and the ratio, look at the size. It's 1 long and this is 2 long. So it starts off 1 and it gets twice as big. This length and this length is twice as big as this length. And this length is twice as big as this length. So the lengths are 2 times bigger. So scale factor is 2. In this question, look at the whichever side is the easiest to see how big it is. This side at the bottom here is 1. The same side here is 3. So it's going to be 1 to 3. And it has 3 times bigger. We have enlarged it with a scale factor of 3. These questions are the same as well. You just have to pick out which side to use. Now in this one, the side A to B, that's like 2 diagonal squares, and this is only 1 diagonal square. So that one would be 2 to 1, which is getting smaller. So it's a reduction. Scale factor 0.5, because it's half as big as the first one. Okay, this is where GeoGebra comes in. So open up GeoGebra and see if you can follow me on this one. We have to draw two triangles, an isosceles and then another one bigger, 3 times bigger. Okay, let's do it. We can go to polygon. Let's make it size 2 at the bottom and 5 at the top. So it goes up 5. The easiest way to do this is to put on another point, which I'm going to put that point there. It doesn't have to be there. And then if you go to here, enlarge from a point, click on the object, and then click on the point. Enter the scale factor. Got 3 times bigger, scale factor is 3. So now we have a second triangle, which is 3 times bigger than the first. Probably think it's getting a bit too big, so we reduce the first one. Now if we move point D around, we can get those triangles so they're not overlapping. If point D is inside the first triangle, then the second triangle will be outside and including the space. But the further away D is, the further the second triangle will move. That's a nice thing to do with the students. Copy the picture, paste it in there, and view. It doesn't take long for the students to get good at this. Okay. Okay, now we're on the more normal exam questions here. I'll just show you how to answer the questions. If you have 32 turnips, draw a circle. How big is that circle? 32. If you want to divide them in this ratio 1 to 3 to 4, well, 1 plus 3 is 4, 4 plus 4 is 8. So we're going to need to give 1 part of the turnips to Andy, 3 parts to Bella, and 4 parts to Katie. So we're going to need 8 parts. So we would divide the circle 1, 2, 3, 4, 5, 6, 7, 8 parts. 1 part would go to the first guy, 3 parts would go to the second guy, and 1, 2, 3, 4 parts would go to the final guy. That's how to do all of these questions. So have a look at this one. That's a bit easy, that one. We've got to divide 30 in the ratio of 7 to 8. So imagine the whole circle is 30 big. How many pieces do I need? Well, I need to give 7 pieces to Andy and 8 pieces to Bob. So I'm going to need 15 pieces. Then how big is 1 piece? Well, it's 2. Because it's 15 pieces from 30 in total. So now I can do it. 7 pieces and each piece is too big. That's 14. And now I need 8 pieces and each one is too big. That's 16. And then we can erase the step like that. Let's try and do this last one here. Now the whole circle is 121 big. That's everything, that's all we have. How many pieces do I need? Well, I've got to give 6 to Andy, 2 to Bob, and 3 to Catherine. I'm going to need 11 pieces. And how big is every piece? Well, 121 divided by 11 is 11. So 6 pieces and 1 piece is 11 big, that's 66. 2 pieces, 11 big, that's 22. And 3 pieces, 11 big, that's 33. And that is how to do all of those questions. Okay, now these are the genius questions that I put on at the end. Bob has 50 bob. He gives 12 bob to Bobby, 18 bob to Blobby, and 20 bob to a bobcat with a bob on a bobsleigh. And the students had no problem with this question. They had more difficulty saying it than they had doing it. So the whole circle is 50 bob. Okay, so the whole circle is 50 bob. How many pieces do I need? Well, I've got to give 12 to Bobby, 18 to Blobby, and 20 to a bobcat. So 12 plus 18, 30, 30 plus 20 is 50. So there's going to be 50 pieces. And because the whole circle is 50, one piece is going to be 1. So that means it's a simple 12 pieces go to Bob, and each piece is size 1. 18 go to Lobby, and 20 goes to the bobcat with a bob on a bobsleigh. That's it. So you just imagine the whole circle is 50, and then you think, how many pieces do I need? I need to give 12 pieces to him, 18 to him, and 20 to him. So 12 plus 18 plus 20 is 50. So that means it's just the same numbers because each piece is one big. That's all it is for that. The enlargements with GeoGebra, if you want to enlarge a circle, say you want to put on a circle there, it's that big, then you put on a point anywhere you want, and then you go here, enlarge from a point, click on the circle, click on the point, scale factor. Let's make it 2 times bigger. Well, that didn't work. The reason why it didn't work was because I didn't click on the circle. So enlarge the circle this time from the point. There's a scale factor of 2. Now we can move that. Now we can move the point G around, and we can see what happens to the new circle that we've just made. Okay, everyone, that's the end of the video, and I'll see you next time. Bye-bye.